Now, next is upon the solids itself, we are having on the basis of arrangement. We are talking about the types of solids. Upon that only, on the basis of arrangement, we are having two types. What is that? Isomorphism and polymorphism. We can say that. Isomorphism. Try to understand the word. Iso means equal. So, what is that? What is isomorphism? When two or more crystalline solids having similar chemical composition exist in the same crystalline form or structure. Alright, when two or more crystalline solids having the similar chemical composition exist in two or more crystalline structures are known as isomorphs. They are called as isomorphs. Two or more crystalline solids having same chemical composition. Here having same chemical composition, they exist in two or more crystalline structures. Not same crystalline structure, different crystalline structures. Two or more crystalline structures. That is said to be as isomorphs, and the phenomena is known as isomorphism. Now, you might be thinking, what is that? See, for example, Na3PO4 and Na3ASO4. These are called isomorphs, these two solids. See, sodium, 3 sodium, 3 sodium. 4 oxygen, 4 oxygen. P and S. They belong to the same group 15, you know that. Alright, so they have got similar structures, we can say that. But different, they have same compositions, but they have got different crystalline structures. So, when they in the same crystalline forms or structures, so different I'm saying sorry, they are having the same crystalline structures. The property is known as, what you can say, isomorphs, and the phenomena is known as isomerism. I'm very sorry, it is not different crystalline structure, the same crystalline structure, same crystalline, iso. I only told you in the beginning that is iso. What is the meaning of the word iso? Means same it is. Same crystalline structures, alright, they are having, that is when two or more crystalline solids, these two are crystalline solids, and this way we can say many more are there, we can say many more, like let us say Na2CO3 and K2CO3. Alright, in this way you can get it, Na2CO3, K2CO3, same crystal, that is two or more crystalline solids having similar crystalline structures, we can say that. This example we can give it. Alright, like we can give CS, that is not CaCO3 of course, we will be getting that is BaSO4, and next one is SrSO4. We can say that, this sort of, or MgSO4, we can say that, clear, fine. Next is, what is that? Polymorphism. What is polymorphism? So, when a particular substance exists in two more than one crystalline form, got it? From the property is called polymorphism, more than one crystalline form, got it? And again I repeat, when a particular substance exists in more than one substance, here two substances it is. When one particular substance exists in more than one crystalline form, it is said to be as polymorphism. Again I repeat, sorry, when the same that is crystalline substance exists in two or more crystalline form in the same substance, it is known as polymorphism, we can say that. Like calcium carbonate, we can say CaCO3. You know it exists in the form of what? Marble. It exists in the form of what? Limestone. It exists in the form of what? Chalk. We can say that. In this way, we can say calcite, aragonite. We can say different names are there for it. As I said, you know, the common names is your chalk, marble, limestone and all these things. Similarly, the chemical name is your calcite, aragonite in this way. So, same substance will exist in different crystalline forms is known as what? Polymorphs. And the phenomena is known as polymorphism. In this way, we can say that. Clear? So, understood what is polymorphism and isomorphism. Now, next is, after that we will come to, that is lattice structure, arrangement of atoms, ions or molecules in case of solid. That is a lattice structure. So, what do you understand by the term lattice? Lattice means definite geometrical structure is said to be as lattice. Definite geometrical structure, that is known as lattice. Okay. Now, what do you understand? Lattice means, what is that? See, I'll tell you the definition. A regular arrangement of the constituent particles. Regular, mind it. What I said you, definite geometrical structure. So, regular arrangement of the constituent particles. Now, constituent particles can be atoms, molecules, ions. Because just now we studied, na? Solids can be ionic solids, covalent solids, network solids and so many. So, such a regular arrangement of the constituent particles, that is atoms, molecules or ions of a crystal in three-dimensional space is known as crystal lattice or space lattice. Alright, when you arrange the atoms, molecules or ions in a three-dimensional space, when you arrange it, listen carefully, when you arrange the atoms, molecules or ions in a three-dimensional space, then it is known as what? Crystal lattice or space lattice. That is said to be as. That is said to be as crystal lattice. Like suppose the 3 points you are taking it in this way. the points you are taking it. You are arranging in a three-dimensional space, this particular points is. Alright, so that is known as what? That is called as and it forms a structure, a definite geometrical structure. Then what is that known as? That is known as a crystal lattice. That's said to be as. So I can give you some examples like cube. Cube is a crystal lattice. Cuboid, another crystal lattice, we can say that. Then triclinic, monoclinic, rhombohedral. These are the different names of the crystalline lattice. Means different name of the geometrical structure. Alright, different name of the geometrical structure we can say. Alright, arrangement of atoms, molecules and ions in a three-dimensional space gives rise to a particular geometrical structure. Got it? So when you arrange in a different manner, you get different geometrical structures. Like as I said, you triclinic crystal, cubical crystal, cuboidal, rhombohedral, monoclinic. So many. There are 7 types of crystalline lattices. I will come to it. Alright, but before that I have to say you something more. Now next is any crystalline solids. For example, this lattice is a crystalline solid. So it's made up of what? Smallest unit is what? That is nothing but a unit cell. The smallest unit is a unit cell, we can say that. So the smallest three-dimensional portion of a complete space lattice, which when repeated over and again in different directions produces the complete space lattice, is called the unit cell. Again I repeat, that is the smallest three-dimensional portion of a complete space lattice. Smallest three-dimensional portion of a complete space lattice. For example, let me draw a cube. Let me draw a cube. So the smallest three-dimensional portion of a cube, the smallest three-dimensional portion of a cube, we can say, let us take that smallest three dimension. This is the smallest portion I have taken it of a cube. This cube is solid, three-dimensional portion. It's a lattice structure. So this is known as a what? This is known as a unit cell. Unit cell. So in this way, if you produce a unit cell lengthwise, breadthwise, heightwise, in 3 different directions, because there we are having 3 directions, na? X, Y, Z. 3 different directions you produce the solid, lengthwise, breadthwise, heightwise. What you will get? You will get a crystalline solid. You will get a crystalline solid, and that is called as a lattice. That is known as a lattice structure. Alright, a definite geometrical solid. That is called as a lattice. So the smallest, again I repeat, the smallest three-dimensional portion of a complete space lattice, which when repeated over and again, in different directions you are repeating it. Alright, you get a complete structure. Clear? What is that? That is nothing but known as a lattice. That is called as a lattice structure. It is said to be as. Okay? This and the smallest one is known as what? It is known as a unit cell. The complete structure is a lattice structure, but the smallest one, this one, the complete structure is a lattice structure, but this one is a unit cell. We can say that. Clear? So as I said you, there are 7 types of lattices. So there are 7 types of unit cell. Because lattice, the smallest unit, is a unit cell. So what is that? Cubic. We are having tetragonal. We are having rhombic or orthorhombic. Then we are having monoclinic. Then we are having triclinic. Then we are having rhombohedral. And then we are having hexagonal. Again I repeat. Cubic, tetragonal, orthorhombic or rhombic, monoclinic, triclinic, rhombohedral and hexagonal. These are the 7 types of unit cells and 7 types of crystalline solids. They differ one from another. These 7 types of crystalline lattice. How they differ? They differ in case of length, breadth and height. They differ in case of the angles. We can say that. Got it? So here the length, breadth and height, that is the parameters. There are different parameters of the unit cells. We are having length, breadth and height, A, B and C. The length, breadth and height. And between this length, breadth and height, we are having the angle. You can see it here, angle is being produced. Here, angle is being produced. Alright, between the length and the breadth, between the breadth and the height, between the length and the height, the angle is produced. And the angle is nothing but here alpha, beta and gamma. We can say that. Alright, so if the length is equal to breadth is equal to height, you know that. In case of cube, what is that? All the sides are equal. Length is equal to breadth equal to height. That means A is equal to B is equal to C. And alpha is equal to beta is equal to gamma is equal to what? 90 degree. So that is known as a cubical solid. Finished. So easy. So which are the examples like copper, NaCl, KCl and all these things. Next, tetragonal. Tetragonal, in case of tetragonal, what you will find is that A is equal to B but B is not equal to C. Tetragonal. We can say that. Clear? And alpha, beta and gamma all are equal to 90 degrees. So we are having a chart in your book. You can see that. You can go through the chart, you can understand it. Along with that, the figure is also being there. Alright, so they are coming under tetragonal. In this way, there are 7 types of unit cells are there. The 7 types of crystalline lattice are there. Alright, thank you.